Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge IGCSE Extended Mathematics Paper 2 on October-November 2024. And this is part 2 for questions from 12 to 23. Question 12, solve the simultaneous equations. You must show all your working. We have 5x plus 6y, which is equal to 9, and then 3x minus 2y, which is equal to negative 17. Now, the coefficients of x and y in both equations are not the same. The coefficient of x in the first one is 5. In the next one, it is 3. Then for y, we have 6 and negative 2. So when you are using elimination, you have to make sure that the coefficients are the same. Okay? So here, I'm going to solve this by eliminating y. Okay? So I have 5x here plus 6y, which is equal to 9. And then 3x here minus 2y is equal to 17. So I can multiply this one by 1 and then this one by 3. So that when I multiply this one all through by 3, I'll get a 6, which is the same as for this one here. So when we multiply, we shall get, this one is 5x plus 6y, which is equal to 9. And then here we get 9x, then minus 6y, which is equal to 51. Okay. And this one is actually negative, so negative 51. Now, we shall add these ones because the signs here are different. If the signs are the same, you subtract. If the signs are different, you add. So 5 plus 9, you get 14. And then 9 minus 51, we shall get negative 42. So meaning our x is going to be equal to negative 42 out of 14, which is actually negative 3. And then we can substitute in any of the other equations. If I substitute in the first one, we have 5 into negative 3, then plus 6y is equal to 9. So meaning y is going to be equal to 9. This will be minus 15. So when it crosses, it's a positive 1. Then we divide by 6. Okay. Then 9 plus 15, that one will give us 24. Divide by 6, that one will give us a 4. So I will write this as a negative 3 and then this one as a 4. All right. Number 13. Part A sequence has the nth term 3n squared minus 1. Find the second term in the sequence. So for the second term, n is equal to 2. Okay. So that means the second term, where there is n, you just put the 2. Second term is going to be 3 into 2 squared minus 1. 2 squared is 4 times 3, 12. Then 12 minus 1, we shall get 11. Then part B, the table shows the first 5 terms of sequences A and B. Okay, they are given here. Complete the table to show the nth term of each sequence. Now, if you look at sequence A, let's look at sequence A here. Sequence A. Now, when you look at this one for A, here they added a 4. Then here they also added a 4. They added a 4. So it's a linear sequence. They added a 4 because it has a common difference. So because it is a linear sequence, then the nth term is given by A plus n minus 1 D, where A is the first term. Okay, A is the first term. Then D is the common difference. Why do we have this equation here? The first term, let me show you. The first term is A. The second term, you are adding something onto that. So you will get A plus D, the common difference. Then the third term is going to be now A plus D. Then now add here a D. So when you add a D there, you are going now to get A plus 2D. Then the fourth term, okay, the fourth term is going to be A plus now 3D. The fifth term is going to be A plus 4D. You see that? Now, the nth term, you can see that all the terms have gotten the A, but I want you to see 5, 4, 4, 3, 3, 2, 2, 1, 1, 0. So that means they are subtracting a 1. So that's why we have n minus 1 here, D. Okay? So you just substitute. The first term is negative 6, then plus n minus 1. Common difference is a positive 4, so times 4, open the brackets. Negative 6 plus, this is 4n minus 4. And this one will give us 4n minus 10. So the nth term for this one is going to be 4n minus 10. Now let's go to sequence B. Sequence B. Let's look at the difference here. The difference is 14. And then here, when you subtract, you get 38. Then these two, they give us 74. Then these ones here, they give us 122. Okay. Then these ones, they are also in a sequence, 24. Then here, 36. Then here, 48. Now, there's another sequence here. Now, when I subtract these ones, 12, then 12. Now, you can see that the third difference is the one that gives us the constant term. So that means this one is a cubic root. I mean, this one is a cubic sequence. So because it is a cubic sequence, let me write something here. This is sequence B. And it is nonlinear. Why is it nonlinear? Because we didn't get the common difference on the first difference, okay, like we did for the first sequence. So now let's look at the positions. So if it is a cubic sequence, okay, if it's a cubic sequence, that means the numbers here, the terms, are related to the cube numbers. Okay, so let's look at the positions. If this is position 1, position 2, position 3, position 4, then let's look at cube numbers. So when you cube 1, you get 1. Cube 2, you get 8. Then here, 27. Then here, 64. Then the terms that we have. The terms, we have 3. Then here we have 17. Then 55. 55. And then here we have 129. Okay, 129. Now, if you get a number here and you multiply it by 2, let's say this one here, 1, I multiply it by 2, then I add a 1. So times 2 plus 1, 18 to 17, 18 times 2, then plus 1. 27 times 2, that is 54. Then add a 1. 64 the same. So that means the nth term here is going to be equal to 2n cubed plus 1. Okay, just like that. Rather than putting the formulae here for an cubed plus bn squared plus cn plus d, this one is going to be a little bit hectic. Okay, and even the space they leave is always limited. So meaning, if you see that it is a cubic sequence, then the formula that they give there is always simple. That n cubed, is it multiplied by a number and then they have added something or subtracted something? It's just like that. You see how the terms are connected to the cube numbers. Okay, so here we shall have 2n cubed plus 1. Question 14. Two solid steel statues are mathematically similar. The smaller statue has height 12 centimeters and the larger one has height 15 centimeters. The larger statue has a mass of 2.5 kilograms. The density of the steel is 8 grams per centimeter cubed. calculate the volume of the smaller statue. And they have given us that density is equal to mass over volume. Now, if the density is given as 8, then the mass is 2.5, and it has to be in grams, because this one is in grams here, per centimeters cubed, so the mass has to be in grams. So 2.5 times 1,000, because we were given kilograms, then over the volume. So when we cross multiply, our V is going to be 2,500. We divide by 8. Then this one can give us 312.5. Now, volume scale factor and length scale factor are connected. Okay, volume of anything is in cubic units. Okay, but the length is always in units. So we have volume scale factor. Volume scale factor is equal to the length scale factor, cubed. So meaning the volume of the smaller one I divide by the volume of the bigger one I've calculated, then is equal to the height of the smaller one, which is 12, divided by the height of the bigger one, then cubed. Okay, and then our V is going to be equal to this 12 out of 15 cubed, then times the 312.5. So putting this in the calculator, we have 312.5 times, this is 12 out of 15, then we cube it. So we have 160 as our final answer. Question 15. Students in Class P take a test. These statistics show information about their marks. The lower quartile is 38, median 53, interquartile range 28, range 81, highest mark is 96. Now, we are told to do the box and whisker plot. A box and whisker plot has 5 values. The first one is the lower value, the lowest value. The next one is the lower quartile. Then we have median. Then we have upper quartile. And then lastly, we have the highest value. Now, since we are given the IQR, okay, which is the upper quartile minus the lower quartile, this simply implies that our upper quartile is going to be equal to the IQR then plus Q1. So our IQR is given as 28, then we add 38, and this one will give us 66. Then also range is equal to the highest value or the biggest value minus the lowest value. So if range is 81 and the highest is 96, then we don't know the lowest. So meaning if I bring x this side, then this will be 96 minus 81, and then the lowest is going to be 15. So when I come here to draw, each small box here is equivalent to 1 unit. Okay, each small box is equivalent to actually 2 units, because you will get 20 and then you divide by the 10 small boxes in between there. So I'll get my ruler, and then 15 here, this will be 10, then 15 will be in the middle here. Then after that, we are going now to go to 30 what? The lower quartile, 38. So 38, I will just go 1 box behind 40. 38 is here. Okay, 38 is there actually. Let me leave some space. Let me leave like 2. Okay, let me leave 2 boxes up and down. Then the median is 53. So this is 50. Then 53 is going to be 1.5 here. So it is going to be here. That is 53. And then next is the upper quartile. Upper quartile is 60. Upper quartile is given as 66. We have calculated it 66. So I move 3 beyond this one, like that. And then the next one is the highest value, which is 96. So I'll move 2 units behind 100. So that is what we are having there. Then these ones, close them. Where the box starts from is the lower quartile, where it ends is the upper quartile. Then these ones, we just connect them just like that. So that one is going to be our box and whisker plot. Then part B, they're saying that students in class Q take the same test. For class Q, the median is 49 and the interquartile range is 35. Make 2 comments comparing the distribution of marks for class P with that of class Q. Now, when we are comparing, we use 2 things. Number 1, the interquartile range. That is we use measures of central tendency, and we also use measures of spread. So the measures of spread here, we are going to look at the interquartile range. How are the figures spread? And then measures of central tendency, we look at mean, median, and mode. Okay, but for this case, we use mean. Now, we are going to say on average. So the moment we say on average, then that means we are talking about median. So on average, the students in class P scored higher marks. It's just a statement like this: scored higher marks. That's enough. But I'm giving this one because the median of P, median of class P, is greater than the median of class Q. Then remember, the median of class P is 53 and the median for this one is 49. But if the median is like the other one is 53 and then for the other is 52, they are closely related. So in that case, we only compare using the interquartile range. Now for this one, for this other one, the interquartile range is 35 for Q. But then the interquartile range for P is 28. So that means the marks scored by students in class Q are more varied, okay, compared to those in class P. So I can say students' marks. By the way, is it about mark? Yes, students' marks from class P are less varied, are less varying or varied or less spread, okay, like that. Why? It's because IQR for P is less than the interquartile range for class Q. Okay, that's the evidence. So you don't need to write this statement here. I'm just putting it there for your understanding. Okay. Question 16. The diagram shows a sphere of radius 6 centimeters and a cylinder of height 18 centimeters and radius r centimeters. The volume of the sphere is equal to the volume of the cylinder. Calculate the curved surface area of the cylinder. So they have said that volume of the sphere. So let me write here, volume of the sphere is equal to volume of the cylinder. Now, volume of the sphere is 4 pi over 3 r cubed. So the r is 6 cubed. Then is equal to volume of the cylinder is pi r squared times the height. Okay, pi r squared height. And then this one can go, pi can go. Okay, pi can disappear, and then we get 4. We can get 4 times 6 cubed, then divide by 3. This one gives us 288. So 288 divided by 18. Then after we take the square root, this will give us the value of r. So the answer we have gotten, divide by 18. Then we take the square root, automatically that one will be a 4. So that means r is equal to a 4. Then curved surface area of the cylinder. When you look at a cylinder, it is here, and then you cut here, then you open it up. What was curved is now going to form a rectangle like this. Okay, but what was here as the circular part, this length here is the circumference. Okay, now it is the one which becomes this length here, this one here. So that is 2 pi r. Okay, in fact, since I've used capital R, since they have used capital R, let me put that capital R there. So that is 2 pi r. Then it has the height, which is 18. That one remains. So that means that the curved surface area here, we're going to say curved surface area, is going to be equal to 2 pi r h. So 2 pi, our radius is 4, the height is 18. Okay, they said give your answer in terms of pi. So 2 times 4, that is 8 times 18, then you get 144. So we shall have our answer as 144 pi. Question 17. Solve the quadratic equation 3x squared minus 4x minus 7x minus 16 is equal to 0. You must show all your working and give your answers correct to 2 decimal places. The moment you meet that, you should know that you are going, the equation cannot be factorized. So therefore, you either use completing squares or the quadratic formula. So the quadratic formula is x is equal to minus b plus or minus the root of b squared minus 4ac out of 2a. Our a is the coefficient of x squared, the b is the coefficient of x, and c is the constant part. So x is going to be equal to negative 7, then plus or minus, then this is negative 7 squared minus 4 times 3 times negative 16 here, then out of 2 times 3. Then negative over negative, that's a plus, then plus or minus 4 squared, that is 49, and then this one will be a plus because the negative times the negative, then it will give us 192, then out of 6. So meaning x1 is going to be, when we take the plus, root of, inside here it is 241 out of 6, and then x2 is going to be 7 minus root of 241 out of 6. Okay, And then these ones are going to give us values. So let's check 7 plus root of 241, then out of 6, what do we get? We get 3.75, and the rest of those figures, so 3.75. That's what I'm going to write here to 2 decimal places. And then the other one, I'm going to put a minus here. Then it will give us negative 1.42. Negative 1.42. Question 18, this one is coming from functions. G of x is equal to 4 to the power of x plus 3. Part A, find x when g of x is equal to 1. So all you need to do is to substitute here 4, x plus 3 is equal to 1. Then express 1 as a power of 4. And you know that anything to the power of the numbers to the power of 0, they give us 1. So we shall have 4 power 0. So meaning x plus 3 will be equal to 0. Because the bases are equated, that means even the powers are equal. Then you take this one this side, meaning x is going to be equal to negative 3. And then the g inverse of this. So for such exponential functions, they want the value of x, which they substituted here to give you a 16. Okay, so let's say g inverse of this is equal to x. Okay, because right from here, okay, when I want to take the g this side, x is going to be equal to the g inverse of whatever is this side. You see that? So this one is going to be x. Now bring the g back here. So you have 1 over 16 is equal to g of x. So meaning we shall have 1 over 4 squared. Then g of x is 4 power x plus 3. Okay. Then this will be 4 power negative 2, which is equal to 4 power x plus 3. Then we equate the powers. Negative 2 is equal to x plus 3. And then bring this one this side. It will be a minus, so x becomes negative 5. Question 19. The universal set is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. P is odd numbers. So right from there, which odd numbers are we seeing? Those are numbers when divided by 2, they leave a remainder of 1. So we have 1, 3, we have 5, we have 7, and 9. And then multiples of 3. 3 is a multiple of itself. So we have 3, then we have 6, we have 9. And then square numbers, that is 1, then we have 4, and then 9. Okay, find P intersection Q intersection R. So what is common to all of them? You can see there is a 9, there is a 9, there is a 9. So it is the only one that is common. So here we shall have 9. And then find Q union R. Q union R. So we put all of those numbers together in Q and R, beginning with the smallest. So we shall have 1, there is 3, there is 4, there is 6, and 9. So we shall have 1, then 3, 4, 6, and 9. Then N means the number of those elements in that given set. So P intersection Q. P intersection Q, then P intersection, then Q union R complement. So Q union R complement, those are numbers that are outside of Q and R. So the numbers that are outside of Q and R and are in P, that's what it means, and are in P because it is an intersection. So outside Q and R, but they are in P. So you check. In Q, there is 3, there is a 1. There is a 1 in R. Then we can see 5 and 9 actually. I mean 5 and 7. These are the ones. They are not in any of these. Okay. They are outside R, but they are in P. So we are having those two there, and they asked for the number, so they are 2. Question 20. The diagram shows 2 right-angled triangles PQS and RQT. PQR and QTS are straight lines. Calculate angle QTR. Angle QTR. When we look at angle QTR, this one here, okay, that angle there, this is the side that is opposite to it. We don't know the side hypotenuse to it and the adjacent side, but I can get this adjacent side if I use this triangle here. Okay, so let's check this triangle. So using SOHCAHTOA, remember these are right angle triangles, and we can use SOHCAHTOA or Pythagoras theorem. So using SOHCAHTOA on triangle PQS, now I can find the QS, okay, QS, then I subtract the 4, then I will be getting this one, the QT, okay. So sine of 28 is equal to the opposite, which is QS, over the hypotenuse, which is 18, meaning when I cross multiply, QS is going to be equal to 18 sine of 28. You see that? So this simply implies that now QT is going to be this 18 sine of 28. Then I subtract, is it a 4? Yes, 4. The ST is a 4. So subtract 4 here. Then we are now going to still use SOHCAHTOA. Again, using SOHCAHTOA. But now on which triangle? On triangle QRT. We are going to have now tan of theta, which is equal to the opposite. I know it as 9. And then the adjacent, the QT we have gotten, okay, the QT is going to give us, we have it as 18 sine 28 minus 4. So meaning theta is going to be equal to the arctan of 9 over 18, then sine of 28 minus 4. So putting this in the calculator, arctan of 9 out of 18 sine 28 minus 4. This one gives us 63.7 to 1 decimal place. 63.7 degrees to 1 decimal place. Question 21. Solve the equation 3 tan x plus 5 is equal to 1. So we can take this one here, it becomes a minus 1 minus 5, we get negative 4, and then we divide through by 3. So that means tan of x is equal to negative 4 over 3. Now that means x is going to be equal to the arctan of negative 4 over 3. Now when you put this one in the calculator, arctan of negative 4 over 3, the calculator gives you a negative answer, which is negative 53.1. But in the domain given here, the answers are positive, the angles are positive. So then how do you do that? I always draw the 4 quadrants. Sine, tan, cosine are all positive in the first quadrant. Here only sine, here only tan, here only cosine. 0, then 90 degrees, 180, this is 270, this is 360. When we move anti-clockwise, the angles are positive. When we move clockwise, the angles are negative. Now, if this is the angle here, theta, then there is this one here. This one will be now 180 plus theta, okay? And then when I project the same angle here, this one will be 360 minus theta, because we are measuring from here, then we come up to here. You see that? Then also project it here. Opposite angles are equal, so this will be 180 minus theta. Now, tan is, so what you need to do, ignore this negative, okay? You get your 53.1. Then you go to the two quadrants where tan is negative. Tan is negative here in the second quadrant and in the fourth quadrant. So you are going to write your answers here like this: 180 minus the 53.1. The other one is 360 degrees minus the 53.1. That is one decimal place. So 180 minus 53.1. This one gives us 126.9. So I'll write 126.9 degrees. Then the other one is 360. 360 minus 53.1, which is 306.9. 306.9. Now these are the answers which fall within this interval. Question 22. The graph of y is equal to x plus 2 into x minus 1 squared is shown on the grid. This one is what we call a cubic curve. Show that y is equal to x plus 2 into x minus 1 can be written as y is equal to x cubed minus 3x plus 2. So what we can do, open the brackets here. So y is equal to x plus 2. When you expand this one, put the square on x, so you get x squared. Then 2 times x times negative 1. Then you get negative 2x. Then square 1, you get that. And then x is supposed to multiply each and everything in the second bracket. So x will multiply with this one, x squared minus 2x plus 1. And also 2 will multiply with x squared minus 2x plus 1. So this one will give us x cubed minus 2x squared plus x, then here plus 2x squared minus 4x, then plus 1. So you can see that this one is 2x squared, can go with this one here, and then we shall have x cubed. Now x minus 4x, that is minus 3x. And then I had made a small mistake here, pardon me. So this one here is a 2. 2 times 1, that's a 2, so we shall get a 2 there. And then next, by drawing a suitable straight line, solve this equation. Solve this equation. So what we need to do is to manipulate this one to see that we get, now we get what we were given. Okay, now what we are going to do is to first get what we are given here, y, which is equal to x cubed minus 3x plus 2. We have to eliminate the x cubed. So how do we eliminate it? I will first multiply this one by 2. That means I will get 2y, which is equal to 2x cubed, then minus 6x plus 4. Then I bring this equation here, 2x cubed minus 5x. This one is equal to 0. Then I solve it from this one here. So I subtract them. When I subtract, I will get 2y. Then this way, this one will be going. Now negative 6 minus minus 5. These ones become a plus. Then we shall get negative x here. And then plus 4. So meaning y is going to be equal to negative a half of x, then plus 2. So we can now look for two coordinates. Okay, we can look for two coordinates here to draw that line. So the line we are going to draw is that y is equal to negative x, over 2, then plus 2. So x and y. When x is 0, y is 2, okay? And when y is 2, for example, when x is 2, when I put 2 here, so negative a half times 2, you will get negative 1, then plus 2, that one gives us 1. So I go to this graph and I plot 0, 2. 0, 2 is here, and then the other one is 2, 1. So 2, then 1. 2, 1 is here. Then I get my ruler. Here you use your ruler, and then I draw through. So this point, it passed through that point there. So that will be the line. And then where it meets with the curve, I come down and I read off that value there. Then also here it is going to be the same thing down here. Okay, like that. Then, in fact, let me make these ones dotted a little bit. Like that. Then we read off those values. So when I read off the value here, let me try to zoom. So this one will be 1. What do you see? 1.5, then 1.6. So I'll write this one as 1.6. Okay, 1.6 as my answer here. Where is it? The last one here is 1.6. And then when you check this other one here, it is 2. Okay, I mean these are x values, so it is on y-axis. X value is 0, so this one is going to be 0. And then the other one here is going to be negative 1.12345. It's almost on 6. So this one is almost on negative 1.6. So, but it is not yet there, so I can say like maybe negative 1.58. Okay, so now we can write negative 1.58. Okay, now since that one wasn't exact, it was in between, they can give they can give a range of values. Like this one, they gave 1.5 to negative 1.6. Okay, and then this one here is 1.5 to 1.6, like that. So if your answers fall within, you are marked correct. Question 23. X minus 5 squared then plus k is equal to x squared minus px minus 21. Find the value of p and the value of k. There are two methods you can use here. Number one is completing squares, okay, or you can expand and equate coefficients. So suppose we expand and equate coefficients. You expand x minus 5 squared. Okay, here we have x squared minus px minus 21. So here we shall have x squared minus 10x, then plus 25, and there is plus k, then this one is x squared minus px minus 21. So this simply implies, you look at the coefficient of x squared here, it is 1, 1. Okay, now get the coefficient of x, which is negative 10, then you equate it to the coefficient of x here, which is negative p. This means that p is equal to 10 if you divide all through by negative 1, so p is 10. And then the constant part here is the 25 plus k. So 25 plus k then is equal to, this way it is negative 21, the constant part, so negative 21. So meaning k can be equal to negative 21, then minus 25, which is negative 46. So negative 46. You see? Then, using completing squares, we can also do this. Alternatively, using completing squares, we can say x minus 5, because this one on the left is in the completed square format. Okay, then this way we are going to have x squared minus px, then minus 21. So complete squares here on the right also. So it will be x, then minus, you get p divided by 2, then square, then pop this one here out, and you square it. So p over 2 here, then squared, and then there is minus 21. So this simply implies that we have p over 2 squared. Then here, this is p power 2 over 4 minus 21. Another person would ask themselves, why are they dividing by 2? And then they put it outside, and then you square. It comes from here. I can have this expansion x minus, let's say, a squared. When I expand this one, it is x squared minus 2ax, then plus a squared. Then I can take this term here that doesn't have x onto this side. So that means we can have x minus a squared, then minus a squared is equal to x squared minus 2ax. Now I want you to look at what is happening here. The coefficient of x here, it is here divided by 2. So you have negative 2 divided by 2. You get that negative a, which is inside here. Then after they square it, and it is the one which is outside here. You see that? So that's why I got the coefficient of x here. It is p. I divided it by 2. Then I popped it outside here, and then I squared it. So always here we are having a minus. Okay, so that is that. Now we are now going to equate what is inside here. The bracket is what is now here. So that therefore implies that we are going to have negative 5 is equal to negative p over 2. Cross multiply. Your p is going to be equal to 10. You see that? And then the constant part k is equal to negative p squared over 4 minus 21. Okay, so k is equal to p squared, that is 10 squared over 4. 10 squared is, remember this one here, we are just squaring p, not the negative, so the negative is on its own. So we shall have 100 divided by 4, which is 25. So minus 25 minus 21, k becomes negative 46. You see? So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.